hasn't responded yet.
There's usually only 4 of us.
I was about to say, yeah, Max and Mac. Well, I don't know. Okay. Stream's up if you wanna. Should be popping up in a second for you guys. Did you get everything figured out on the number 2, Anna?
Yeah, I got it.
Okay. Alright, moving on to number 3 then, on part B. That should have been easy for you guys, hopefully.
Yeah.
Questions on number 4? I don't think that should have been too bad. Number 5, if you graphed it, shouldn't have been bad. I guess you didn't really have to graph it, you could have done it by hand. Just broke it up into 30 integrals. Number 6.
I need help with 6.
Okay. So at this point with those kinds of things, because you're not doing an actual antiderivative, you're kind of looking and seeing which ones of those is the derivative, more or less. So the easy way to realize is it's not a product, or it's not a quotient, or Jesus, I need to wake up this morning. It's not a chain rule. So you can't have e to the x inside of something and then take the derivative of it, because you're going to multiply then by e to the x.
Yeah.
So it can't be like a. B is a giant quotient rule full of, oh my god, I don't know what the derivative would look like. So
whatever we're like, the answer choice would be the derivative of the f of x function.
Antiderivative.
Okay, so it's like whatever the.
So I would just start looking at the derivatives of those functions that they give you. Now, if it's a normal function, obviously you just take an antiderivative, do a u sub, et cetera, if you want to. If you're struggling, even on other like normal problems, you could just take the derivative of the functions they gave you to see which one it works out to be. That would have been an option. So here, like I said, I would just look at these and say, okay, well, clearly these are not, it's not going to be just straight up a normal derivative or normal thing. So like a is close to the derivative of f of x, which is not what they're looking for, because the derivative of tangent is secant squared. So that's clearly going the wrong way. B, like I said, I have no idea what that giant cluster is. I don't know where they got the idea for that from. I'm going to click on it and see. Okay, they don't even show what the derivative would be or anything. They're just, yeah, I don't know. Like yeah, maybe it's just the hardest looking thing. So maybe some people pick it. I don't really know. I don't know where they got the idea for that one from. C is an option, like on the outset of it, but again, that would require a chain rule, because when you do the derivative of that, remember you're going to have to take the chain rule or the derivative of your limits of the integral, because that's going to create a function inside of a function when you do all that. And I can show you what I mean if you need to. So the answer is clearly going to be D there. Do you need me to show you what I mean by anything on like C? What the function inside of a function idea? Is that understandable? Okay. 7 should not have been that bad for you guys. Yeah, it's just integral from 4 to 8, whatever that weird shape ends up being.
Yeah, that's fine.
Alright, Anna ever come back, Rudek? With her eggs?
I just got back. Good timing there.
Okay. I went over a couple of them, so that's why I wanted to. Did you have
I
any
did
questions
okay on
on?
this one, so I should be good.
Okay. We're on number 8 now, so you can catch up.
Okay.
So they tell you what to use for U sub, which is something they have done in the past on multiple choice, and then made you change your bounds and stuff like that. I don't think that should have been an issue for you guys if they gave you U. The hardest part to remember is just don't forget to switch out your DU. Number 9. So you had to figure out what your U was, which shouldn't have been too bad for you guys. Good on number 9. Dave silence is a yes.
I said yeah.
I didn't hear you, Sweetie. Number 10. Everybody got number 10 for real?
Yeah. It's just a U sub, but it's an arctan.
Yeah, well, I mean, it's not easy. You got to complete the square and stuff like that with the negative sitting out front and everything. It's not the easiest one. Not the hardest thing, but... I guess I probably would have just taken the derivative of the arctans and see which ones it was, to be honest. 11 shouldn't have been too bad then if you did number 10, so it's just arc sine. Alright, 12? Oh, Jesus. That looks...
12. I just forgot. Oh no. 12 was long division, I
Yeah.
think, so that's okay.
It just
But
looks...
will you? I forget with long division. How to do the remainder part. Like I know how to do the first two, like the whole number parts when
Mhm.
you're getting whole numbers, but I don't remember how to do the
So your
remainder.
remainder goes over your divisor. So in this case, you should have had a remainder of 1. So that'll be 1 over x squared plus 1.
Oh, okay.
Barry, I saw you lit up green. Did you try to say something again? Because I did not hear you. If you did.
No, I didn't.
Okay. There's Max. Okay, so yeah, section B much easier than section A apparently. Yes, much better results on section B too for some reason. Okay. Alright. Section C. I was getting ready to say this is C. You don't know how to do this, but I forgot this is BC. So question number 1. So hopefully everybody recognizes that's integration by parts. Taking the silence as a yes. Question 2, again, integration by parts. That's the theme of this section so far.
Hold on, I'm trying. My computer's trying to load.
Okay.
Okay, I got it. I'm ready.
Question 3. Were you trying to say something, Tinder? Because you came in as static.
I was trying to fix my mic. I couldn't hear you for the last like minute. So where
Oh.
are we at?
We're on question 3. Do you have any questions on number 1 or 2?
Wait, we're on C. Okay.
Yeah.
No, I'm good. Wait, no, I missed one.
Number 1, integration by parts.
I probably just messed it up somewhere. I know how to do it.
I would do tabular. just because it's quicker. It's a quicker method, and 1 goes to 0, 1 repeats itself over and over and over.
Yeah.
I haven't done section C yet, so I'll do it tonight.
Okay. So far, it seems to be nothing but integration by parts. We'll see what else we have in here. So just remember
So
that formula. Go ahead, Riddick.
yeah, will you do number 1 so I remember how to integrate by part?
Yeah.
Okay.
So do you remember the formula?
U D U U.
So you have the integral of u dv.
Oh yeah.
That's a, so we have our formula for integration by parts, which is the integral of u dv is equal to uv minus integral of v du. So that is the basic one. Now, if you remember, we also had the tabular method, where one side was u and one side was your dv, and then you did u prime, u double prime, u triple prime. And this would become v. See, I hate doing it this way because it's always hard. You gotta keep going up. I guess so. You would have the integral of v. And then double integral of v. There's not really a good way to do it notationally, unfortunately. So one side you take your derivative, one side you take your antiderivative. Because if you look, every time you're going to go, you're going to switch them. So you're going to do the integral of this one, but the derivative of this one is going to keep going in a pattern, and then use the lines, and it is plus, minus, plus. And it can keep going forever until you need to stop. The idea here is that something here eventually gets to 0. So the idea that you're looking for most often in tabular is one to be a very easy integral, and one to be a very easy derivative that eventually goes to 0. So usually the only things for the most part that go to 0 are polynomials. There's some other rare cases where it'll happen, but typically if one's a polynomial and one's something that can repeat, such as e's or sines and cosines and stuff like that, that's what you're looking for. So if we do number 1, it'd be 4x plus 5, and then 4, and then 0 for the polynomial part, and e to the negative x. And if this is e to the negative x, when you're taking the antiderivative, it's you got to compensate for the negative each time. So it just cycles around like that. Plus, minus. So your antiderivative of whatever they had would be a negative e to the negative x times 4x plus 5 minus 4e to the negative x. That would be your antiderivative. And we have bounds of 0 and 2. So you evaluate that at 0 and 2. So plug the 2 in, you get negative e to the negative 2, 13 minus 4 e to the negative 2, and then minus, when I plug in 0, that goes to 0, but that does not. So minus 4. And then e to the negative 0 is 1. So we get negative 17e to the negative 2 plus 4, if I did all that right. Ooh, plus 9. Where did I mess up?
So if we can't use
that part's not
tabular,
0.
we do the thing at the top.
Yes, and I can show you the same one here. That I messed up on the right-hand
Okay.
part. I wasn't paying attention enough. So when you plug in 0, the whole thing's not 0. It's 5 e to the negative 2 minus. Oh, no, just minus 5.
Add e to the 0.
Yeah, and then minus 4. So that'd be plus 9. There we go. Now I got it. Just wasn't paying attention to everything. Now, if you can't use tabular, which isn't sometimes an option, you do your u's and your v's. Remember, so you set up your chart. U is equal to v is equal to du equals and dv. So your u and your dv come from the original problem. You pick u to be something that you can take a derivative, and dv something you can take an antiderivative. So usually I pick v first, pick something you can take an antiderivative. Well, in this problem, very easily, we can do an antiderivative of either one. So you always pick your most complicated one that you can take the derivative of, or the integral of if you can. So in my case, that would be e to the negative x, and then dx. So the antiderivative of that would be negative e to the negative x. And then my u would be the 4x plus 5, and then du is just 4. So then when I go to plug it into my formula up here, I get uv. So I get negative e to the negative x, 4x plus 5, minus the integral of v du, which is 4, negative 4 e to the negative x. I forgot my dx, going crazy. And then you just do the antiderivative of this part. The whole idea is that the integral that you get in your new part is something you can very easily do, which here I can very easily do this antiderivative. So this becomes negative e to the negative x, 4x plus 5. Double negatives becomes a positive, but then when I integrate, I get another negative, so it'll be minus 4e to the negative x, just like we got over there. And then we would bring our bounds back in at that point and evaluate that from 0 to 2. So you can use either method, but if one of them goes to 0, tabular, in my opinion, it takes less work. Any questions on either method there that I used?
I'm good.
Okay. Any questions on number 2 then? 2 should be pretty straightforward. What was 33? That looked weird. 3's not too bad. You just have to realize that you're going to make your dv the h double prime of x. That's going to be the one you're going to have to take the antiderivative of, even though you don't actually have the antiderivative. You just know it's h prime of x.
Do you take me just looking at it? I know I wouldn't be able to do it, so can you just go ahead and do it?
The whole idea there is that, again, you're taking the derivative of one of them, setting it goes to 0, which is x. And the other one, even though you can't actually take the antiderivative of it, you know the antiderivative of h double prime is h prime. So that would be the...
So this is another tabular?
I would do tabular, yeah, because this one goes x1, 0. This one's h double prime of x, which turns to h prime of x, which turns to h of x, tabular, plus, minus. So the antiderivative of the function they have there is x, h prime of x, minus h of x. And then you evaluate that from whatever to whatever. I need to go to Office Depot and buy new markers. And then they gave you select values of h, h prime, and h double prime. So you just evaluate it from 1 to 4 and plug in the values they gave you from the chart for that one.
That makes sense.
Yeah, if you look at their explanations, it appears they don't use tabular, which I don't know why, but they use the just straight up formula, but it's the same thing.
You can only use tabular if one you take the derivative goes to 0 and the other integral.
Right, if your one derivative doesn't go to 0, you're never going to stop. That's why you can't use tabular on those problems. The more actually complicated problems that you would ever run into, which I've never seen on AP, are ones where it cycles around over and over. So for instance, let's say the left-hand side was like sine or cosine, and the right-hand side was like e to the x. Eventually they're going to cycle over and over. If you want me to, I can show you one at the end of class today. That's up to you guys. It's what you would be what I would consider the more difficult integration by parts problems. Let's see, 4. Let's see. That's not arc because there's no arcs there. So I'm assuming with all the ln's, it's probably partial fractions. Yeah, partial fractions.
I never got past 3. So,
How did you not get past 3?
well, yesterday we only got to number 2 of the next one, so I just thought it'd be the
But
same.
the problem is we have absolutely no motivation right now.
Well, I can't fix that, very unfortunately. I can only keep my high requirements of you and then do my best to make you feel bad, I guess. I don't know. I understand the lack of motivation and everything. Trust me, I really do. But we've got to push through. You got right around a month, a little less than a month, and then for me, you'll be done. I'm like literally, once that happens, you're done. But I can't help anything else on other classes. I understand everything going on. You know me, I really do. But at the same time, I've got to keep that high requirements and not relent on them until everything's done. Just like last year, even through the hurricane and everything, I kept those high requirements and it worked out. It was better circumstances in some ways than this, I know. In other ways, it was worse, but
Honestly, like everyone keeps comparing this to the hurricane, and like don't get me wrong, the hurricane was awful, but at least we got to go back to actual physical school and after that month was done.
I understand, like I said, some things of that were worse than this and some things of that were better than this. I completely understand and agree, and I'm not going to compare it and say, oh, it's not the same. It's just difficult circumstances is the same idea there. But yes, I completely understand. You guys, you're talking to someone who I miss all of my students tremendously. The fact that I don't get to see them on a regular basis, even though I'm talking to you guys, I don't. It's different, and I know you understand this. Other people may not, but it's a huge deal to me. Like that's it's a giant part of my life, like you guys are. So it's very difficult for me as well. So I completely understand that. The only thing we can do is push on, push through it, try to do the best we can, and not lose out on anything. I don't want you guys to not pass this upcoming test. I don't want you to feel bad about it. I don't want anything of those circumstances to happen. I want you to be prepared. I want you to be successful. That's the reason I keep pushing and keep going. It's I really would rather just not have to do any of this stuff and just be like, oh, it doesn't really matter, but it does. So we have to keep pushing through. We have to do the best we can. And I understand it's rough. Don't ever try to think I don't. But you've got to have that. You got to have those people here to help push you through. Um, and that's really what I do and why I keep my high requirements and my expectations, because that's something that me, I don't drop them. My expectations don't get dropped for any reason. I didn't drop them last year, even though we lost a month of school. We still pushed through. I kept those high standards for you guys, and you all succeeded. You all performed to the level that you can, and then same thing's going to happen here. I can't let my standards drop just because of that. Now, did I modify slight things and give you a little bit less work and give you a little more freedom because you guys have done what you've done already? Yes. But at the same time, I can't just be like, let's just not worry about any of this. We've got to get through it. Hopefully that makes sense.
Yeah.
Yep.
Okay. So 4 would be partial fractions as you go back and look at that one. 5 is more partial fractions, but they've already factored it for you. That's very nice of them. So this is your BC integration, is what this is. Okay. More partial fractions.
And you have to like factor the bottom, so you can do like an A over one of the factors and B over the other factor, right?
Mm-hmm.
In this case, you just took the 6 out, or like for number 4, excuse me, you just like, since the 6 is a constant, you just took it out of the integral.
You can do it that way. I would not. Because when you're doing partial fractions, you need the top to equal something. So you could take the 6 out and then multiply everything through by 6 after you get your a and b values. That is a possibility, but I think that's just extra work, so I would not do that. So when you do it, you'll do so you'll factor the bottom, which factors into, obviously you factor out an x. So you get 6 over that equals a over x plus b over 2 plus 3x, and then multiply through by your common denominator and solve for your a and b value. Because if you factor out the 6, your a and b values are actually going to be very not friendly. They're going to be fractions. So that's why I wouldn't suggest doing that. Does that make sense, Bergen?
Kind of. I think I'm gonna have to work through it to understand what you're saying.
That's fine. Like I said, just work through them, and you can text me later. I obviously don't have much else to do, so. So you got a couple of partial fractions, then you get to 7. 7 is your improper integrals. Why is 7 an improper integral? What's the issue there?
You can't plug in 1.
Yes. So you do have to be very careful. On the outset, this problem looks super simple. Oh, that's ln. No problem. Done. Got you. However, the issue is that you cannot do that because at 1, that function has a vertical tangent line. So you cannot do that. You have to be on the lookout for that. They're not going to tell you that it's an improper integral. You're going to have A, B, and BC stuff mixed in. Whether this actually comes up this year or not because of the circumstances, I can't tell you. But you do have to remember to check your integrals for those points of infinite discontinuity and things like that, jumps, undefined points, etc., etc. You've got to remember to check for those. So especially here, you run into issues with 1 because you will get a if you did try to take your ln and plug it in, you'd get ln of 0, which you can't do. So fortunately, that wouldn't mess you up. Excuse me. Because you get that it's divergent, so you can't do it. So you probably would have picked that either way, even if you didn't remember that. But you do have to be extremely careful and remember to look for that. Number 8 is an easily recognizable improper integral because it has an infinity in your integral. So that one won't be too bad for you guys, I don't think. That one actually ends up having an answer. That's nice. Okay, on number 9, they give you the antiderivative.
What did you say about 8?
Hey, Dad. Should be an easy. Notice that it's an improper integral because it's got infinity in your integral, which we didn't do until BC. So that's the whole put the limit there, evaluate it, and then solve the limit.
Yeah, gotcha.
And that one has an answer, so it's not too bad. It's a pretty easy one. Okay, so they gave you the antiderivative. Okay, so they're basically asking you why it's divergent. So that is a BC integral because when you go to plug in pi, you get ln of 0. So you can't plug into the antiderivative. Really, you have to. Yeah, that'd be. Clearly, the answer is not A or B. It doesn't have an answer because when you plug in the pi, you get issues. They're A and B are throwing you off if you don't know what cosine of x is, or cosine of pi is. And hopefully everybody remembers cosine of pi is -1.
Would it be because you can't plug it into the antiderivative, or because Or can you plug it into?
So
Or would it be because you can't plug
two
it into
options.
the actual?
You can't plug it in. It's not necessarily divergent because the function, like if you think about part number 8, you have issues with the plugging into the original function. That's fine, depending on what happens to your integrals. Remember, we've had some really tricky ones where we like combined ln's and things like that. The problem comes about when you can't plug in, or not necessarily plug in, but do the limit of the antiderivative. Um, in a lot of cases, you can't plug into the original function, but you can do some manipulations to the antiderivative and get a value still. So that is possible. So it's not that the fact that I can't um, do, and especially the limit. You can do a limit for C. You might be able to figure out what that is because you get 0 over 0. So that might have an answer actually, if you understand what I'm saying. Especially since it's from pi to the left, usually that does have an answer. But it's the fact that you can't do it into the antiderivative. So remember when we do all of our limits and stuff like that, the limit doesn't come into place until after you've done the antiderivative. So that's why it's not C and it is D. So we actually never even evaluate part C to understand anything. We never do the limit on the original function. Let's see, 10 looks to be by parts because one goes to 0, one recycles. Yep. 11 partial fractions most likely. They don't even have you actually do the actual antiderivative or anything. They just have you figure out which one it is. Yeah, A is definitely not correct. B is also definitely not correct. So yeah, that's easy to tell out A and B. And for C and D, you just got to figure out which one's negative, so you have to do a little bit of investigation on finding your A and B there to figure out between C and D. 12. Oh yeah, 12 is super easy. You guys should all be able to do 12 without a problem.
Since it's a common denominator, I can just like split it up into 4 fractions, right?
Yep, that's exactly what they did. If you look at all their answer choices, some of them are just wrong. I don't know where the wrongness comes in, but exponents probably, it looks like, yeah. And I'm assuming since we didn't finish our multiple choice, we didn't finish our free response either.
Not the three supposed to.
Definitely not.
I'll be doing it tonight though, or trying at least. I don't remember half this stuff.
Yes, you do. Let's see. I just want to take a look at it real quick and just see what's on it. Max.
Really tough thing I've ever seen, Max. It looks like it's pretty much done.
I actually haven't been by it lately.
I'll buy it. Like,
So the outdoor patio is basically done. The inside's done. We just have to. They have to finish like little things on construction, and then we can start like the decorations. But like everything's back ordered because of the whole virus. So like all of our chairs, all of our like benches, all of our tables, everything's just not here yet because they're not working. You know what I mean?
hey, at least you won't disappoint people by not being open for Cinco de Mayo.
Yeah, people will understand. No, my dad was saying that my dad's main problem with it is that like the new restaurant's gonna need like 8 cooks when originally the old restaurant only had 4, and so those 4 cooks are now working at different restaurant, like they're working at like Guadalajara, one of our other restaurants. So and when those restaurants get super duper busy during the summertime, so my dad doesn't want to pull all of the waiters and cooks that relocated after the storm to like the other locations. He doesn't want to pull them in the middle of the summertime and leave the other restaurants with bad service. And that's why he's considering waiting until later in the summer once everyone's settled down and we can figure it out better to open.
Understandable.
Max said, "Can I cook?"
Berrigan's like, nope.
Diego's is still popping though, especially with the gallon margaritas.
Dude,
No,
they,
Diego's sold like I think they sold like $8,000 one day. Like that's a lot.
yeah.
Wow.
Well, it does help when they have $5 gallon beer.
Hey, and the thing is, people have to buy food in order to buy the alcohol,
Oh, do they
Mhm.
really?
and that's the rule that the governor set in place. Like you can only buy alcohol if you bought food to go with it.
Yeah.
Which makes sense. How much is the gallon margarita?
Already
On
opening.
the specials, like the special days, it's like only $5, and then regular time, I think it's like 10 something, 12 something.
Yeah.
Wow.
People really don't understand margaritas really aren't that expensive. Like when you go to a restaurant, you actually get charged quite a bit for a margarita. Most of a margarita is nothing but
If
mixers.
you get a top shelf, it makes sense. Or
Yeah.
if you
Well,
get like because we have like the mix, but that's not what our most popular is. Either the top shelf margarita or the skinny margarita, which is like not made with mix.
well, not even just necessarily mixed, but it's mixers like other stuff. It's not like alcohol. That's what people don't understand. Like it's a relatively large drink, but it has a very low amount of alcohol compared to some other drinks. Even if you make like a fresh one, like even at like higher quality places where they like make fresh stuff and they don't use like an actual margarita mix, you're still using non-alcoholic mixers for the majority of a margarita. So it's really just like a shot of tequila and a little bit of um, like liqueur. Is really what a margarita is.
Are we all gonna go taste test margaritas together?
Um, you can do the same
Valid.
thing that BC from last year is doing. Once you all turn 21, we can go. Not until everybody's 21 will
What?
I go.
Not, not fun
That's the one.
or fair.
Well, that's the rule. I don't do underage drinking because, well, not happening. So yes, once you all turn 21, they've already planned. I guess they want to do something. So if you guys want to do the same thing, you're perfectly fine.
I'm sending my resume to Los Rancheros. I'm going to work there.
Okay, so you do realize that Berrigan's just gonna put your name on a blacklist, right?